Welcome back. This unit 0.1 will talk about data world. The contents we'll discuss in this particular unit would be specific to chapter 1 from the assigned book. The learning outcomes for this unit, unit 0, are to identify different data formats and their role in answering real world questions, and also to understand the process, the list of processes involved or the list of steps involved in order to answer these real world questions. Keep in mind, we start with the real world question and we try to answer the question. And we use different data formats to do that. So, one outcome is to understand different data formats and their role in answering these questions. In trying to answer these questions in the real world, we need to follow some specific steps. So, you need to identify what these steps are, or at least recognize these steps that you need to answer these questions. The first step is to identify the data set, then get access to the data set, then evaluate the nature of the data set, then clean the data set. Once you clean the data set, then you analyze the data set, then you visually represent in some format. So these are the steps that you will take where you start with the question and try to find an answer. In doing so, you follow these steps of identify, obtain, evaluate, clean, analyze, and visualize. So, um, one outcome is to be able to understand at least the basic definitions of these steps, like what does it mean by identify? What does it mean by obtain, evaluate, clean, and visualize? Then the other objective is this is a big picture, right? The main another main purpose is main objective is to understand the main purpose of this class. The main purpose of this class is to help you develop these skills specific to answering questions related to the real world. The question can be related to real world issues like COVID situation or related to gender bias based on data, and so on and so forth. So one main thing is you should be able to describe the main purpose of this class, which is to develop answers to questions pertinent to real world data specific to global issues using these 6 steps, namely identify, obtain, evaluate, analyze, and visualize data. In this unit, we'll first talk about data, try to define it, then talk about different types of data files, different types of data, and the Open Data Initiative specific to accessing data. Then we'll talk about the theoretical framework specific to utilizing data. Then I will talk about a brief history of data, and finally we'll end by talking about different types of data files. Let's define data now. Now, before we define data, let's understand the word, how it is used. Data refers to data in its pluralistic form, and datum is the singular form of it. So you can say there is datum or there are data. Now, coming to the definition itself, very general level, at a very, very general level, when you say data, you're referring to information in general. And you can find this in um, Webster or Oxford dictionaries, where data is defined as information. Now, this is not the only definition of the word data. And we look at the secondary definitions in the next slide, and we'll also look at um, other aspects of the word definition, other meaning aspects of the word data in the next slide, in addition to the specific definition that we will follow in this particular class. Let's look at the secondary definition. And usually, information It is defined as the information that is stored in a computer. Or sometimes it's also defined as information that can be stored digitally in a numerical format. What it means basically is that it's not only information, but also information that is stored in a device in a digital format. More specifically speaking, we are referring to this digital format of information in the form of bits. A bit is a basic unit of information. It is stored in the form of binary coding, like zeros and ones. For instance, let's say your name is stored as 011001. So the very idea of the word data not only implies that it carries some information in it, but that it is stored in a device digitally so that it can be transmitted, transformed, or transferred to a different device digitally. Sometimes the meaning of the word, like data, also is specific to the context in which you are using it. For instance, for the purposes of communication, data refers to evidence. What data do you have to support your claim? What data do you use to substantiate the point you're trying to make? So data is also used to refer to evidence. Now, what I want you to do, and you'll see in the attached PDF file, the active links that you can use to actually access very short readings on this particular topic, referring to the Tolman's idea of an argument and how Tolman used the word data to refer to evidence. So please don't forget to read those two short um, writings on the topic specific to the use of the word data referring to evidence and supporting a claim. Now let's come to the specific definition that we will use when we refer to the term data. It is defined as it is defined in the assigned book for this class. Now, we take into consideration the point that it is information. That's one aspect of it. Number one, this information is stored in the digital format in the form of bits, zeros and ones. Also, the idea that this particular information is represented and stored in specific kind of computerized files like this, for instance, Excel. So it is not only information, but it's digital information, a digital information that can be and is stored in a computerized file. And the information is stored in such a way that it can represent text information like your name, number, for instance, your social security, or dates, and other kinds of information. And also the idea that this kind of file that stores these different kinds of information referred to as data can be manipulated. So you can make changes to it and save these changes. And you can use different kinds of programs to actually manipulate and save this information, like Excel sheets, spreadsheets, database managers. And we'll talk about all these things later. And the idea is that data now is more dynamic, where it carries information in the digital format, and it carries information of different kinds in the digital format, and it can be manipulated using specific programs like Excel, and it can be transmitted from one device to another device through networks, for instance, internet. And this is what we'll refer to when we use the word data in this class. Now that we have defined data, in the next slides, we look at the different types of data files. At a very fundamental level, you can define um, data files into two different types: data files with raw data and data files with summarized data. Now, what do you mean by raw data and what do you mean by summarized data? Now, let's look at the survey, getting to know you survey that you already took um, before actually beginning of the semester. Um, and let's look at this. If you remember, you were asked several questions um, in this particular survey, right? Let me try to. Uh, you were asked several questions on this particular survey, and I tried to hide your names here by using X's. So for each of the question you were asked, you gave me several responses. So this data file is a raw data file with each of you giving responses. At the time when I created this presentation, only 4 of you had actually given responses. So 4 of you answered these questions. So 4 of you with responses to each of those questions will make up raw data file. And this data itself, which is part of a raw data file, is the raw data. And so raw data refers to the actual original data without actually trying to make sense of it. Now, what if I convert this into a more summarized data? Well, in that case, I can look at, let me try to, yeah. So if I summarize data based on your response and specifically try to look at one particular question I asked in the survey about what is your favorite color and try to see, and I gave you 4 options, let's say, or you gave me options and those fall under these 4 categories, for instance, blue, black, green, and purple. And if I try to summarize or represent this data in the data file in the form of like how many of these students actually said they like blue? How many said they like black? How many said they like green? Again, I had to make up these numbers because I had only 4 participants here. So this way of representing data is the summarized form of the data. And this kind of data file that represents information in the form of summaries is called a summarized data file. Now we just looked at the different types of data files based on the kind of data it stores, whether it is summarized data or raw data. But summarized and raw data are not the only two kinds of data. You can use a different category, different criteria to actually categorize data, and one of those categories is the nature of it. And that's what we'll talk about in the next slide. Now, now the data itself can be categorized based on the nature of it. When we say nature, we are specifically referring to the source of it into two different kinds: primary data and secondary data. Primary data refers to the data that is collected by you, the original data. It is not the data that somebody else had collected and made it available to others to analyze it. So most of the experiments, most of the scientists that collect data from through different experiments, that data refers to that data is the primary data. That is the data you can think of, the raw data the scientists collect, right, and store. That is the primary data. And you can either summarize data or you can share data. If the data is shared, then it becomes the secondary data. Secondary data is the data that you, when you're using as a user, is not the one who has collected the data, but it is collected by somebody else, but it is made available to others to actually process the data. In fact, we'll talk about the initiative that led to providing data to the society We'll talk about it in the next slide. But for now, just think of secondary data as the data that is already available. For example, your census data, it's already available there, right? For us to utilize it, summarize it, and analyze it, that kind of data that you are not collecting, but you're using to answer some specific questions is the secondary data. Now, if it's a class like a research method class in a psychology department, like I teach that class, we work with the primary data. Students actually develop research questions to answer, and then they collect primary data to answer those questions. What you'll do for this class, though, is we'll use secondary data, data that is already available on the web, and use that data to ask important questions and answer those questions by summarizing that data, by analyzing that data. The data itself that is secondary either can be in the raw form or it can be in the summarized form. And different kinds of data sets are useful for asking and answering different kinds of questions in the real world. So we'll learn more about secondary data, how to identify secondary data, how to locate important secondary data, and what kind of questions you can ask, and so on and so forth throughout the semester. Okay, the next slide we'll look at Open Data Initiative. Now, most of the data that you will access or um, obtain will be from online resources. And the reason we can actually access this data is because of the government initiative, often referred to as Open Data Initiative or Open Government Initiative, where they're required to provide this information to um, general people. According to the Open Government Initiative, many of the government agencies, including municipalities, counties, and states, are required to make their data available um, for as web applications for transparency and for making decisions. Either it is available in the summarized data form for especially those who are not trained in making sense of such data, but they also mostly make this data available in the raw format. And especially for people like you who can access this information to make sense of the raw data. Let's now turn to the theoretical framework of data utility. I mean, the theoretical basis or understanding of how data is utilized and how it is useful in making sense of the information. And that's what we'll do in the next slide. Acuff in 1989 proposed a model called Data Information Knowledge and Wisdom Hierarchy or Pyramid. The idea is this: data by itself doesn't give us any insight unless you act upon that information. In that sense, data is only a means to get to more higher levels of understanding of the world around us so that you can make more meaningful, informed decisions. In that sense, we can climb through the steps of the pyramid, but the foundation is the data. Let's understand in detail what it means. Now, when you say data, we're specifically talking about the raw data. And this data itself is basically um, raw, unprocessed digital information about people, about objects, about time, about individuals, about anything in the world that would help us make sense of the world or nature. Now, this unprocessed symbol, they are meaningless, simple data points, but they form foundation to our um, understanding of the world around us if we can utilize it properly. And the steps that he proposed were the basic being the data, the next is the information, followed by knowledge, and finally the wisdom. And our main purpose should be, in the long haul, to be able to gain wisdom through the data that is available in the world. Let's look at the information then. If data is the raw information that is not processed, which doesn't give us any information or is not meaningful by itself, information is more processed information. Information is more processed uh, um, information. And we usually use computers or some sort of Excel sheet or other programs to kind of make sense of this raw data. So this meaningful form of data is information. You can think of it roughly as summarized form of data. Then comes the knowledge level. Knowledge, this level, we use the data. After summarizing the data, we kind of make sense of it by creating some new information that is not directly stated either in the data or in the information stages. We kind of reflect on these summarized information and try to create knowledge which would help us make decisions. So, this level of information called knowledge is something that is in a form that we can utilize it in the real world. For instance, teachers can, it will be useful for teachers, it will be useful for policymakers, it will be useful for analysts or for MNC companies to kind of make decisions about what to do next. So mere meaningless data points would make data. Some sort of summary of it would make information. Then your reflection on the summarized information to make inferences such that you can utilize it for decisions that would make up knowledge. And the last one is wisdom, which is basically getting so good at using data that you will eventually be able to know how to appropriately use data. You become more wise, you become wiser. So, um, well, I can't help you get here right away in a span of a semester. What I can do through this semester, through this class, is to help you learn skills to be able to use data and convert into information, use the information to create knowledge, and eventually, by repeating these steps, you become a wise person. That is the idea here. Now, Awad and Ghazari in 2004 modified this model or hierarchy, if you will, and kind of added this additional information suggesting that in this pyramid, data is the only step where you can use algorithms, the mathematical manipulations of information, like you do by using computers or Excel sheets or other programs. So these are more programmable. And knowledge and information are less programmable, less um, accessible to the programs or algorithms. Um, and when it comes to wisdom, it's completely non algorithmic or non programmable. What it means at a basic level is that the basic data point itself can be processed through algorithms and other programmable things. And the higher you go in this pyramid, it becomes less and less specific to algorithm and programs or computation. It's less of computation and more of your insight. So when you climb these steps, you're actually going from getting used to using different software and algorithm to actually becoming more wise at reflecting on the summarized, analyzed information. Okay, now let's look at a brief history of the data. How did the idea of data start? We'll go back as far back as we can, even looking at the remnants of the idea of data and how it all started, where it is now. Keep in mind, it's a very brief history. Well, according to the discussion in the book, you can trace back to the origins of data to 220,000 BC. The idea here is that at this time is when um, people invented arithmetic and different kinds of tools to manipulate numbers. The very idea of numbers, that's what it refers to. Then, in kind of around 1700 BC, then more standardized form of manipulating information and measuring information and multiplying information is um, invented, if you can say. Later in around 500 BC, right, Greek scholars and others um, gave a better understanding to us of the very idea of numbers. So, according to this discussion in the book, if if you look at the brief history of data world, the beginning was all about numbers. Then, during Renaissance, Nicole Orsame, if I pronounce it correctly, developed this idea of using these numbers to represent it in the form of graphs. And later on, Wilhelm invented a machine that could add up to 6 digits. So if you look at the idea of evolution here in terms of use of data, we very early on we understood or tried to make sense of numbers, followed by representing numbers in the form of graphs, followed by developing some tools like machines that could actually manipulate these numbers. You see the progression here, the slow progression here. Then something more happened during industrial revolution and even more during digital computers. And now we have more advanced level of computing. And the basic idea is this. It all started with numbers. It all started with numbers. Then different ways of representing numbers. Then different machines that can represent these numbers and manipulate these numbers. And in a very at a very even basic level, these are not just numbers. These are symbols. A symbol is something that represents something else. Okay, to end this unit then, We'll end it with this brief discussion on different types of data files. But most importantly, we'll focus on the kinds of data files that we will explore in this class. Okay, so let's look at the data file formats. A data file is um, a digital file that holds information, that holds data. Now, keep in mind that there are different types of data files in general, though. For instance, you take, for instance, your computer, it stores images, it stores videos, it stores text files, Word documents. It stores all different kinds of data files. Usually, a data file kind can be um, ascertained by looking at the extension of the file. When you look at the name of a file, for instance, it says Shri dot whatever the extension is. So this dot extension, this is called the extension. For instance, dot doc, right? Dot png, and so on and so forth. These are called extensions of the data file. This gives some information about the kind of data it holds. Um, and these different data formats, keep in mind that these different data files are storing the same digital information that is represented in a binary code in ones and zeros. Even if it's an image of me or my name, eventually a computer would store this information in the form of zeros and ones. So in that sense, anything the computer stores is a digital file. Hence, it is stored in different formats depending on how it is stored, uh, um, or what it is stored, and how it is stored eventually is in the zeros and ones. Now, um, let's look at this idea that although there are different types of formats, file formats. For this class, though, we will primarily focus on Excel file formats. We call them native Excel file formats. The file formats um, that are often called Excel workbooks. Excel workbooks, and it comes in two flavors or in two formats: .xlx format or .xlsx format. XLS, XLSX. It is an older format, and this is a commonly used format. It's before 2007, and after 2000, since 2007, we have a newer format of the Excel with an X added at the end. And according to Microsoft, we the XLX format is more user friendly, and you can do more with this file format in terms of moving from one digital computer to another, or in terms of manipulating the information, and so on and so forth. Again, we're not going in deep about different data files and everything. Just to give you a basic idea that any file that holds information is a data file. But we are primarily focused on the data files of the Excel kind. And these Excel kind data files come in two forms, .xlx, XLS, and .xlsx. Um, then there are the, so because we'll use Excel primarily, it is important to understand what kind of other data files can Excel operate on. So in other words, we'll look at other Excel compatible formats because we're primarily working on Excel. So the commonly accessible and freely available data files that an Excel can manipulate or use or open or process would be something along ODS format, Open Document Spreadsheet format, or um, the DBase format, So again, we'll cover more of these later on. Even more than that, it's important to understand that knowing the different kinds of Excel formats is more important. As we go through different data assignments, then you learn more about the other Excel compatible formats. Finally, we'll end this data file format topic by moving on to one such very um, important data file format that is not an Excel format, but a non-Excel format that is very useful, where you can read, process, and interact with the information in a text file in XLX, XLXX, and many other programs. That format is called text file. It comes in different flavors like .txt is one kind of text file, .csv, comma separated values is another kind of um, text file, tsv, tab separated values, .tab, .prn, .dat. These are all different types of text file formats. A text file format is the simplest kind of format. It's the most useful format, especially for us because we'll be working in Excel. Uh, then these files, text files, are unique because these files use a specific standard of storing characters. It's called ASCII. Again, I'm not gonna give this. You can read it from the book. This kind of format or this kind of standardization makes it this particular file very readable in all available forms or kinds of operating systems or computers. So you can read in the mainframe, you can read in servers, Macs, PC, Linux, whatnot. Um, and these text files come in different formats. Again, we'll not talk more about it. Just keep in mind, text files are the most versatile kind of file formats, and they usually come in this .txt, .csv, .tcv, and .tab, and so on and so forth. But eventually, keep in mind, irrespective of the data file format, we will operate on data files in this platform. That is the Excel format. That is the fundamental thing that you have to keep in mind. We learn different ways of um, what do you say, accessing other data file information um, and tricks to do that in the Excel platform later on. Okay, so we looked at these topics, um, and I hope you um, enjoyed learning these topics. And the next slide, you can review the same learning outcomes for this unit that we started this unit with to kind of. Well, we started with the Unit 0 learning outcomes. Now we are ending with the Unit 0 learning outcomes. Now that you watched two video lectures, Unit 0.1 and Unit 0.0 and Unit 0.1, what do you think? Do you think you can do these things? Well, give it a try. Thanks. Stay tuned. I hope you're having fun learning in this class. I'm having fun. Thanks.